All right, so today we're going to continue we'll start on Jdbc today, and we might finish that on Thursday depending on the weather. We do have a continuation of instruction policy in the syllabus. That continuation would just be me live streaming from home instead. So I only mention that because the forecast at one point said 8 inches on Thursday. It's now gone down to 3 inches, so hopefully we won't have need of that, but regardless, it'll still be a live stream from somewhere, okay? So to finish off what we were talking about last time was that there's this object-oriented programming model, and then there's this relational model, and they are different because the relational model predates the object-oriented programming model by at least 20 years, right? Well, at least 10 years, more like 20. Remember that we are online, so if you have any questions, go ahead and post to Piazza or to the live stream. Right? Anyway, we have to resolve these two, right? We already identified that one of in the relational model, our relational model only has data, right? The object model has behavior, right? What else does the object model have? And inheritance, right? So we've got the concept of class and subclass, and in the relational model, we just have tables. So for example, if you have an asset and a stock is an asset. Hopefully you put that into an inheritance hierarchy. How do we do that? Do we have a table for each? A table for one? A table for all? How do we resolve this basically? All right, and there are several strategies, right? There are several inheritance strategies. There we go. So I'm going to go ahead and talk about all three, but then I'm going to really highly encourage you to take care to elect to use one of them. All right, there is a table per class strategy. Right, each class. Each class, both intermediate subclasses, classes, and superclasses, all have one table each. Right? So, for example, let's come over here to your lab 5, remember, where you had this employee payroll system. You had an employee. We're going to ignore the interface here for a second. We had an employee, an hourly employee, a salaried employee, and then we even subclassed the hourly employee to have a temporary employee and a staff employee here. If you took this table per class strategy, you would have, because we have 5 classes here, you would end up having 5 tables. How do you simulate the inheritance? Through a one-to-many relationship then, or a one-to-one relationship depending, okay? So that's 5 tables, right? Each table would only hold the data relevant to that table. The employee table would have an ID, a first name, a last name, and a title, right? If you can't see that very well, there we go, right? The hourly employee would then inherit, right? And I'm going to put those into double quotes there because you're not actually inheriting because it's not an object model. But through a one-to-many relationship or a one-to-one relationship, you would have 2 records one in each table related to each other. And then in the subtable, right, then you would have an hour employee subtable with hourly pay rate and hours worked. Right? Then you would have yet another table for temporary, right? Potentially, if there were if there was any data down here. Right? So if you like having table after table after table, then a table per class strategy is probably the way to go. Right? Or you can have a table per stub class, right? One table for each terminal class that you make, right? Subclasses. That would relieve you of the need of having so many tables. Instead, with this inheritance hierarchy here, instead of 5 tables, now you're down to only 3 tables, right? You would not have a table for the employee class. You would not have a table for the hourly employee. Instead, you would only have it for the stubs, the actual, the ends, right? The leaves of this tree. You would have a temporary employee, a staff employee, and a salaried employee. And then you would have duplication of data because all of them have an ID and a first name and a last name and a title. You would have all 4 of those columns in each one of those 3 tables. Right? So yes, there's repetition of data there. Right? That goes kind of against the relational model to begin with. So maybe that's not the strategy that you want either, right? But these two are perfectly valid strategies, and they are used out in the wild. But what I'm going to tell you to use is the single table inheritance strategy. Right? Where you have one table for all subtypes in a hierarchy, right? You may have some columns that are used in some records and ignored in others. For example, again, let's go back to the assets and the stocks. What is something that a stock all assets have? All assets have a code, right? So all asset records would specify this. Right? Another example. What is something that's unique to a stock? Only a stock has a share price. Only stocks, options have a share price, right? So for stock instances, it is present. For non-stocks, right? What's something that's a non-stock? For property, say, it would be, how do we designate that this thing is not there? No, exactly. So in other words, you would want to allow a share price to be a nullable field, right? And it's used in some records depending on the type, and it's not used in other records depending on the type. So how do you distinguish whether or not this one record, this asset record, is a stock, a property, an option? How do you do that? To distinguish types, you use what's called a discriminator column, right? A single or string or character to denote the type. Now, this is a big no-no in your Java classes themselves, because if you have a stock class and you have a getType function, you are doing something very, very wrong, right? Sure, if you want to return a string representation of it or something like that, fine. Do it in a toString method, right? But if you have a getType char or something like that, you're probably doing something wrong, because that's going to tempt you to break encapsulation and compute the value of a stock outside the class. The class is the type, right? You don't need a letter to designate S. This is a stock, right? But in a database model, a relational model, you do. Why? Because there's no inheritance. So how do you model inheritance? That's when you have a discriminator column like this. And that's why we put it in the CSV file, right? So, for example, over here in this hierarchy, I'm going to zoom out here. I would only have one employee table, right? All records would have ID, first name, last name, and title. So in other words, should those be allowed to be null? Probably not. Every record would have those. Some records will have an hourly pay rate. Well, all of them will have the column hourly pay rate and hours worked and annual salary. But depending on the type, hourly employee, these two would be null, and then this one would be present, right? And vice versa, okay? And then you don't need anything for these two subtypes here other than yet another discriminator column. And you can encode that as a discriminator column. Discriminator column is just a varchar, and then you put in, S, P, O, or something like that. You can even do a custom discriminator column value. You can have the whole word spelled out, option, stock, whatever you want. Okay? When you load it up, you look at that discriminator column to determine, should I be creating a stock instance or should I be creating a property instance? Right? That is by far the simplest way to go about doing this. So keep that in mind as you are designing your database for your design doc this Friday, right? Especially if you're having to put in an ER diagram. If you want to, go ahead. Go ahead and try doing the table per class strategy. You will quickly find that you need how many tables? For asset, then there are 3 subtypes, and then there are 2 option types under that. So 6 tables or 1 table. Which one do you want to do? Hopefully one table. Right? That's why we're suggesting that you do it that way. Okay. All right, questions on that so far? Otherwise, let's talk about Jdbc here. Okay, here we go. I'm not going to start a new note set. I'll just go ahead and start a new header here. So Jdbc, which is Java Database Connectivity API, right? So Java Database Connectivity, and then his API is a separate word here, right? So our goal is to programmatically connect to and interact with our database. I'm going to continue working with that film, director, actor database that we had before. In fact, I'm going to go ahead and get rid of this now, right? And remember what that looked like, right? We had a film, we had directors, we had actors, and then we brought films and actors together here with a film actor table, that join table in between. And I've got this open just so that we can take a look at the values that we put into this database. But you know, I'm interacting with the database through MySQL Workbench here. This is a MySQL client, right? I can put stuff in and take stuff out, but that's all a manual process still, right? It's me writing this Java database code. Ultimately, this is going to be in some sort of a project or some sort of a user interface where a user can enter data into a web form or something like that, and then it can be processed and persisted, saved to the database. Or an application will pull all the information and then display it in a nice HTML table or something like that, right? Ultimately, we want a program to interact with our database rather than us sitting here typing SQL code and then dumping it to a file and then putting it up on a web page or something like that, right? We need to programmatically connect to the database. In other words, we need to write some Java code that will go out to our database, make a connection, pull the data, formulate a query, execute the query, pull the data, and then display the data however we're going to, whatever we're going to do with that data, process the data, okay? Most languages have support for this kind of interaction, right? It's called database connectivity. And that's why it's database connectivity API. JDBC stands for Java Database Connectivity API, but more generally, there's ODBC, which is Open Database Connectivity API. It's even more general than a single language. If you're working in, say, Python, I forget, I think that there's PyODBC. There are a couple of other options as well. You know, a PY, DBC or something like that. But any language is going to have some sort of library for you to be able to connect to and interact with a database. Just to remind you what an API is, it's an application programmer interface. So if you remember back to the solid principles, the last principle was dependency inversion. We will not be writing code to connect to a MySQL database. We will be writing code to connect to a database, a generic database, an interface, because we want to invert that dependency. We don't want to have to rewrite our code if we change our database to a Postgres or move over to a Microsoft SQL server or something like that. I don't want to have to change a single line of code. Instead, I want to just have to change that thing in between, that dependency inversion. There's this driver, it's called a driver, and our code will program towards that interface. This driver implements that interface, and we don't have to step on each other's toes, right? That a database a database vendor like Oracle can publish this driver, and you can use their driver without having to change any of your code because you've programmed towards the JDBC API, application programmer, right? Again, it's a perfect illustration of dependency inversion. You don't program towards a specific database, you just program towards that generic API. As far as JDBC is concerned, we are going to work with 3 objects, and only 3 objects from that database. I'm going to keep it simple. There are dozens and dozens and dozens of classes defined, or interfaces actually defined in this API. We're only going to worry about these core 3. With these 3, we can connect to our database, connection, right? We can make a statement, we can prepare a statement, and then when we can execute that statement and get a result set back. Over here, if I were to execute, say, this, where I've flattened the entire data model, This right here is being presented as this kind of Excel table kind of. That is a result set. Each one of these is a record that I can pull out. For each record, I can pull out a particular column value, right? And we're going to do that programmatically, okay? I will mention, not for bonus or anything for that or like that, but I do have an extra video on more modern ORMs, which are object relational mappings. JPA and Juke are two of them that are in Java. If you're interested in those, go ahead and check out that video and check out that project. Basically, it allows you to not have to write any SQL at all. It allows you to say that this class, this variable in this class is associated with this column in this table, and it takes care of all the boilerplate for you, right? So it can save on code, but you really need a very, very clean mapping between your object model and your relational database model. Right? If we have time, as bonus, maybe we'll do something like that. But otherwise, we're going to focus the rest of the day here on a demonstration. The demonstration is that we are going to, I'm going to set up the project here. Ooh, you know what? I didn't unroll this. So ignore this for a second. Delete this. Yes. Yes. There we go. All right, good. And run configure. Nope. Properties. Nope. Dang it. Build path. Configure build path. Ignore what I'm doing. I'm just taking this off because I made sure to test it before I came. Remove this. There we go. So this is what your project would look like right now without having a JDBC connector in it. Okay. My first step is to download that connector. Again, it is a dependency inversion. We're only going to program towards this interface. To actually connect to a specific database like MySQL, we have to go to the company that produces this database, the vendor, and we have to get a jar file from them that connects to that specific database. Once we put that in our project, we're good to go. We don't have to do pretty much anything else. That's why it's so easy to change. We could go to a Postgres and say, I'll download their jar instead, replace that jar, and now we're connecting to a completely different database. The database that you're going to be connecting to is MySQL. So we need to go to Oracle. Oracle publishes this as something called Connector J. Right. And we go to Oracle, download Connector J, MySQL. Don't worry, it's Java, so it is platform independent by its nature. Just go ahead and say platform independent, download a zip or tarball if you want, whichever the case may be. No thanks, I don't want you having my information. Ultimately, this will give you a zip file, and I'll save that. And let me open it and show you what it looks like. Okay. Yeah, there we go. All right. So there's the expanded folder. All I need is that jar right there. Right. I'm going to go ahead and drag and drop that into my project. Drag, drop into a lib folder, which you should be using for any other libraries that you have. Right. Once I've got that, how do I add it? Build path, add to build path, and now we're good to go here. Right. I can start writing JDBC code. Okay. So what we're going to do is we're going to do several things. We're going to connect to the database and pull directors. We're going to connect to the database and pull data on films and actors and everything. We're going to pull all the data out of the database because we want to display some result that looks something like this with all this data right here. Okay. So there's a very basic outline for this process. Right? Just like opening a file, you open the file, you process the file, you close the file. It's basically the same process. Right? So the process is you create a connection to your database. You need a username, a password, and a URL. You create and prepare your query. You prepare the query, then you execute the query. If it gets results back, you process those results. And then you clean up after yourself. Right, close your resources. We're going to close that connection. If you don't close the connection and it just sits there and hangs, it's not like memory that gets cleaned up at the end of the program. You could cross your fingers and hope that the connection gets reset or the connection gets closed when the program dies and is done. But if not, then your connection will sit there for 5 minutes or so, wasting resources, and eventually it will close because, of course, the SQL server will say, you've sat there and done nothing for 5 minutes. So I'm going to go ahead and close that connection now, and it'll be reset. If you open connection, open connection, open connection, and leave them all open, eventually you will run out of connections. I think that you have a 30 connection max on that server because they don't want you opening 1 million connections and then not doing anything with them. That's a waste of resources. So we're going to make sure that we clean up after ourselves by closing our resources, just like a file. You open up a file, you process a file, you make sure that you close that file. Okay? All right, let's just go ahead and get into it over here. I've got several functions that I want to write here. Let me go ahead and zoom in here. There we go. We'll go ahead and get the director by their ID. We can get a director by their name. And I've already designed all of these objects over here. What kind of objects have I designed? There's an actor object. There's a director object. There is a film object. What is a film object composed of? A ID, title, director, and a list of actors that represents the cast. That's where my join table comes in. Okay. So this is a very nice, clean mapping, right? How many tables did I have in the original database? 4, but one of them was a join table. How many classes do I have over here in my Java? Pojos, plain old Java objects? 3. There's a 1-to-1 mapping there, right? As long as you've got a well-designed class hierarchy, that should immediately translate over into a well-designed table design in your database. Okay? All right, so what's my first step? Which one do we want to do first? We'll come back to saving data later on. Right now, I'm just interested in loading data. I'm doing this in a data loader class. And I've got a bunch of static methods here. Right? We're going to connect to the database, given a director ID, and we're going to produce a director object that has their ID, last name, first name, and we'll return that. So let's document that. Connects to the database and loads data associated with the given director ID record. ... Right? Whatever. So that 4-step process, we need to connect to the database first. Okay? So to connect to the database, I'm going to create a connection. Let me see. Just a second. Right. Yeah, we're not going to do any of that yet. Right. So string URL. I need a URL. I need a password. And I need a username. String user is equal to me. Your user is going to be you. And your password is going to be your password. I'll tell you my password. It's 1234. And this is why I told you not to use a password that you care about. You're going to be putting it in a plain text, a plain Java source file here. The graders will see it. Your partner will see it. If somebody decompiles your source code, they will be able to see it. Right? So there's a password that I do not care about. Right? Now, where do we connect? We're going to connect to the CSE server. And the URL for that is going to be looking something like this. This may not look familiar to you, but if I changed it to, say, HTTPS, would that look familiar to you? Yeah, what is that? Hypertext Transfer Protocol Secure Socket, right? HTTPS. If you go to a website, it's using that protocol. We're not going to a website. We are going to a MySQL server. So there's our protocol. It's a Jdbc MySQL server that we're going to be speaking to. There are many other protocols out there. For example, does anybody know SMTP? Email, exactly. Simple Mail Transfer Protocol. FTP, File Transfer Protocol. SFTP, Secure File Transfer Protocol, et cetera, et cetera, et cetera. So we're going to connect using, a MySQL protocol. And that's not an official protocol. It's just it's telling the driver what to use. Okay. Now, which database are we going to connect to? we then provide the database name. If you're connecting to your database, of course, you would change this to your name. And because we can't have anything this simple, we also have to cut and paste this. All right. Don't worry about any of that. When I push these out to the notes, when or when you go into your lab next after spring break, this string will be there for you. It is to get around certain misconfigurations between the database server and this current driver. If you want to use Unicode is true, we set that to true. And then there are time zone shift issues with the configuration on the server that we all take care of with this URL. Don't worry about it. All right? But otherwise, I've got a URL, a username, and a password. Now all I need to do is make a connection. Con is equal to null. Right? And I'm going to try to make this connection because a lot of things could fail, right? What if I mistyped my password? And instead it was ABCD, right? 1, 2, 3, 4. Right? So if anything goes wrong, what happens is it results in a SQL exception, E. Right? And unfortunately, this is one of those checked exceptions where I am forced to surround this with a try catch. Right? That's because it's kind of old. I think MySQL or the Jdbc was added in version 2. And so that was back when they still thought that this was a good idea, unfortunately. But if you want to use a modern way of doing this, like, say, JPA, they have no checked exceptions in JPA. They have no checked exceptions in Juke because those were made when everybody realized that this is a bad idea, after everybody realized that this is a bad idea. Okay? It's SQL exception, right? Yeah. Why are you not? Did I not import it? Oh, okay. I'm not doing anything to cause it yet, so we will do something to cause it here. I'm going to make that connection. Driver manager dot get connection. And I'm going to provide the URL, the username, and the password. There we go. Now again, if for any reason this fails, for example, you have a bad password, this will throw an SQL exception, and then you can decide what to do about it. What should we do about it if I've got a bad password? Can you reasonably recover from a bad password? No. This is a non-interactive program, right? We're writing this program so that we don't have to do the manual connection, query, process the results. It's all going to be programmatic. So I will simply just say log an error message, system.error.println, cannot get connection. And then what do we do with these exceptions? We catch them and release them. We throw them back. So throw new runtime exception, E. Right? That is an unchecked exception that I am not forced to surround with a try and catch. Right? Let's go ahead and see it in action here. Right? Come on. Okay, apparently it's not going to let me do that because, come on, play. Oh, because I'm not doing anything. I'm not actually calling this, duh. Right? So that's just code. It's just sitting there. Do we have a director with a particular ID? Matt Reeves. So this is data that we did in the other section. Matt Reeves is the director of The Batman, and The Batman has who's in it? There he is. No, we did this, didn't we? Robert Pattinson as the Batman and as Bruce Wayne. I think I put him in there too. Yeah, he's both Batman and Bruce Wayne. And then we've got Paul Dano here as the Riddler. Right? So we're eventually going to pull those out from that film. But Matt Reeves is the director, and he has ID 1. So director D is equal to this. And let's just make sure that it works. Again, we're not done. We're far from done here. System.out.println D. And we'll see that this results in an exception because access denied because you're using your password, yes, but it's the wrong password. There is no way that we can reasonably recover from that. Let me go ahead and come back, 1, 2, 3, 4, and show you that, in fact, no exception will be thrown. But of course, we're not getting anything back from this. We're returning null, and we're ending up printing null. Okay? In fact, yeah, there it is, null. Okay? So we've made our connection. Now what we need to do is we need to formulate our query. All right, so here, let me let me comment as we go along here. 1, make the connection, ... 2, formulate your query. Queries are simply going to be strings. Query, there we go. So how do I get the director information out based on, say, this director ID right here? If this were SQL over here, right? In fact, this is how you probably should be developing. You'll have both of these things open. You will debug your statement over here, your SQL statement. Select everything from director D, where director ID is equal to 1. There we go, Matt Reeves. That's the query that I want. And if you've got that query, bring it over here and put it into your string. Strictly speaking, you do not need the extra semicolon. That'll be taken care of for you. But whatever you're going to do, be consistent about it. Okay? This looks fishy. We'll come back to that much later. But otherwise, I want everything right now because I want the first name, last name, and the director ID, even though I already have the director ID. Right? So maybe I want to winnow that down or something. All right. Am I always going to be selecting out Matt Reeves or whatever his name was? Nope. So what should the director ID be here? Cardinal sin. Never director ID. This is a concatenation. You are opening yourself up to an SQL injection attack, which is the #1 attack avenue for websites. Right? I hesitate to even show you that. Instead, we are going to make sure that we prepare statements properly with a question mark, because I don't know what it is. Right? Literally, you put in a question mark. Right? Now let's go ahead and prepare this statement, because we've got a variable within our statement here that needs to be set. We need to replace that question mark with the director ID that we were given as part of the input to the function. Okay? So I'm going to create a prepared statement. PS, right? Is equal to, actually, I'll say null first, right? And then I'll try and prepare it. PS is equal to, my connection is what I'm going to prepare it with. So remember that I called my connection con up here, right? You can say connection, you can say C. Connection is too long to type over and over and over again. C is too short and non-descriptive, so Goldilocks it right in the middle. Con, right? Con dot prepare, not prepare call, dot prepare statement. There we go. And I'll give it its query. There we go. All right. What that does is it sets up a statement that now you can go in and through the interface, you can change that question mark to an actual value. And to do that, I'm simply going to go say ps dot set, and is it what type is this going to be here? Is it a string? Nope, it's an integer. So I will set int the first one to be director ID. Right. Now let's parse through that. If this were in fact a string, then I would set, instead of setting integer, I would say set string. Right? If it were a Boolean, I would say set Boolean. Right? If it were a different type entirely, whatever type it is, then you would set it to be that type. Since it's an integer, I will set an integer. Right? 1. How many question marks do you see in this query? Just 1. The indexing starts at 1, unfortunately, right? It's different than all other indexing that you're used to up to this point with most other programming languages, right? It's setting the first one. If I had a bunch of them and last name equals a question mark, if I had 2 of them, then I would set the first one, 1, and then to set the second one, I would set int 2, or set string 2. We'll see another example later on here where we set 2 strings, okay? But otherwise, there's only 1 here, so we set the first one to, these are called parameters. We set the first parameter to the director ID, okay? Then to B, right? Execute your query, right? And to do that, I will say ps.execute, right? Isn't it just execute query, sorry. Execute query. Now, if we look at the signature for this execute query function, what does it return? It returns a result set because you're selecting stuff out of the database. So we need to capture that result set. RS is equal to null. And RS is equal to that execution of the query. Let me go ahead and import that as well so that it compiles. If anything goes wrong in any of this stuff, guess what happens? An SQL exception is thrown. Oops. There we go. So cannot get a connection. The message here will be different. Cannot get data. I don't know, whatever you want. All we're going to end up doing is throwing an exception here. What could cause that? Bad SQL. Misspelled tables, right? Where foo director ID is something like that. Misspelled columns, right? Anything, lots of stuff could go wrong here. And if anything goes wrong, then just this generic SQL exception happens. Again, can you recover from that? Can you recover from somebody that doesn't know how to spell select? No. So that's a you need to go back in and fix this bug. We can't recover from it. We'll just rethrow it this as a runtime exception. Okay. Once I've got the data to see, I guess, process the results. ... This result set is a result set. It's exactly like this thing over here. Right? Initially, there's a pointer, it's called a cursor, that is pointing before the current record. What we will do is we will iterate through each one of these records if there are multiple records. Now, if I select out one single director, are you going to expect that there are multiple directors with that ID? Probably not, because that's our primary key. But if you had, say, selected out all the films, then we would need to iterate through all of them. So what I'll do here is I'll show you how to iterate over them. Then we'll fix it so that we have an expectation that there's only one. While rs.next, I will process the current record, right, row. rs.next will advance that pointer to the next one. So if there are four results here, right? Initially, it's pointing to before the first one. Next points to the next one. In this while loop, I'm going to go ahead and go next, next, next. When do we stop? When we're no longer pointing to any valid record. At that point, rs.next returns false. Before it was returning true. rs.next, yes, this is a valid record. rs.next, yes, this is a valid record. True, 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 right? And then only when you're down to the last record does it return false. I'm no longer pointing at there's no longer any record for you to read. It's kind of like the scanner and reading lines. While you have another line, read the next line, right? While you have another record, go to the next record, go to the next record, go to the next record. Right? Within this loop, we are now pointing to a current row. What we need to do is we need to process that row. So string first name. I want to get out the first name. rs.get string, because first name is a string. And what's the name of the column of the first name? First name. String last name. Last name. And also the ID. I'll go ahead and get it out just to show you how to do it. Int director ID. Granted, I already have it. I already set it, right? Director ID from database, since I've already got it, right, is equal to rs.getInt, and the column name is director ID. Right? Now, arguably, you shouldn't have this line because you already have the director ID, right? So I'll just leave that in there as a demonstration, right? But I never went back to my database to say, what was the first name of the director? What was the column for representing the first name? Right? Why not? I'm using the exact same style in my database that I am in Java, right? What did I name my table again? The actor table. What's my class name? Actor. The director? The class name is director, right? What was the table name again? Director, right? There is a one-to-one correspondence between all of these things, and there's no guesswork because I followed the same naming conventions all over the place. Okay. All right. Let's see. Once we break out of this, then we no longer have that director. So what do I do with this data now? I need to create a director, right? So let's come back up to the top here and create a director object, D. I'll initialize it to null because you could be asking for a director that doesn't exist. We'll talk about error handling here in a second. But if it does exist, then I will say D is equal to new director, and I will pass in all the things that are in the constructor, director ID, first name, last name. I think that's the order, but let's check it out. It's first name, last name. There we go. Okay. I've got my director now here, and instead of returning null, I'll return D. Let's go ahead and execute this and see if we get back Matt Reeves. Hey, Reeves, comma Matt. Now we're getting data out of the database. Okay. What did I skip? Step 4. Did I close any of my resources? Nope. Now, likely they're not. They were closed automatically by the database, by Jdbc or something like that, and it was a good steward of its stuff. But if you've got a long-running process and you want to keep this stuff open, or you accidentally keep it open, right? Then that is a problem because eventually you will run out of resources. Eventually, if you have a memory leak, you will run out of memory, or your performance will degrade to a point where it does everything grinds to a halt, right? So let's clean up our resources. ... I'm going to close everything. Con.close. Right? I'm also going to close the prepared statement. ps.close. And what else did I make? rs.close. That's the order that I created them in, though. Is that the order that I should close them in? So the same theme here with the hierarchies of tables, with the same theme of hierarchies with inheritance strategies. If you work one way for creation, you work the other way for destruction. Right? If I have a parent-child relationship between two tables, I can't have orphans. So if you want to delete a parent, you need to delete the children first, and then you can delete the parent. Likewise, if the prepared statement depends on that connection, and also the result set depends on that prepared statement, and then transitively to that connection, you need to close them off in the reverse order. There. You created them, connection, prepared statement, result set, you close them in the reverse order. Now, unfortunately, because of decisions made long time ago, this can also result in an SQL exception, cannot close for some reason, ... So in fact, unfortunately, it looks like, well, no, I didn't do it here. Okay, yeah, that's good enough there. You can go ahead and take this and hoist it up to here instead if you really wanted to, so that you'd have one less try-catch. You could surround this entire thing in a big try-catch, right? But by separating them up into different chunks here, we are being a little bit more fine-grained. This is just one query. If you had query after query after query after query, you probably would want to break that up a little bit. But you can, if you want to, treat this all as one big giant try-catch. All right. I think it was working before. It's still working now, but it's actually cleaning up after ourselves. And there are all the connections are actually closed. In fact, I can show you what happens when you don't close a connection. Right, let's go ahead and, here. I'll get rid of all of this stuff here. And come over here. I think I'm still using my database, so I'll show you all the process. Show process list. There we go. So it looks like there's my persistent connection by MySQL database, MySQL Workbench here. There's my process that asks me how many other processes are there, including the one that asks the process, right? And right now my Jdbc code over here is not, connected at all, right? But let me show you what happens when we fail to connect, right? System dot sleep, is it? No. System dot wait. No. What is it? I should have looked this up before. I forget how to force a Java process. I don't want Spotify. Where's my web browser? Here we go. Java sleep. Where is that? I thought it was system pausing. Thread.sleep, maybe. Thread.sleep. There we go. And I'll sleep for, say, 5 seconds here. 500 milliseconds. Right? And I probably have to surround this with try catch. All right, there we go. So let me run this and see that It'll print it out, and then it'll go to sleep for 1, 2, 3, 4, 5. You see that it's still running here, right? That'll give me enough time to go back and see that stuff is still open. In fact, let me give myself 10 seconds here. All right, running that, and come back over here, show the process list, and there it is. It's been asleep. Or no, which one is it? It's right here. It's been asleep for 2 seconds here. I'm sitting there with this connection open, wasting resources, sending signals back and forth over the network just to keep it open. Maybe there's memory both on my end and memory on the server end that's being tied up with this persistent process. And only after you close it, let me get rid of this now and show that you can actually close this. And it did die. It waited 10 seconds, then it died. I'll run it again. And it's still waiting 10 seconds, but we will see that that connection now has been closed, and I only have the 2 connections from before. So again, failure to close your connections, you will eventually run out of them. If I called this 30 times, I can guarantee you I would run out of connections, and it would then die. Right? Watch. Right? Go ahead and get rid of this. I will not clean up my resources. And instead of getting the director once, I will, for int I equals 0, I is less than 100, I plus plus. I will do it 30 times, never closing that connection. And then let's make sure that it's sitting and spinning thread.sleep so that we can actually look at it for 10 seconds here. Not 100 seconds, I don't want that. All right, surround this with a try-catch. There we go. I will run out of connections here really, really quickly because I think that the limit is 30. There we go. What does it say? Max user connections exceeded or something, right? And hopefully they're all closed now, or we're going to be waiting. Okay, good. It automatically closed them all for me. Otherwise, we were going to be waiting here for 5 minutes to do anything else, right? If you ever find yourself in that situation, you may have to sit there and wait for 5 minutes for all the connections to be reset. There's not an easy way to close those. Okay? So make sure that you are cleaning up your resources and not loading the same director 100 times. There we go. All right. That's pretty good. But now let's go ahead and do it in a different way. What if we wanted to get the director by their name instead? Right. So director, what other directors do I have here? Nope. I've got Christopher Nolan there. Christopher Nolan. So let's load him up. All right. Director Nolan is equal to get director by name. We do have to provide a name here. In fact, we have to provide an entire director object. So what I'm going to do is I'm going to create that object. Director D is equal to, Nolan, key, I'll say, new director, and I don't know, null, and Christopher Nolan. There we go. And I want to actually get that record from the database. Why am I doing it like this? With just a first name and a last name, isn't that good enough? Why would I need to load it up from the database if I've already got that information? What information do I not have? Their ID. Why would I need their ID? To connect them to a movie, right? I need that as their primary key as a foreign key to a movie record. So this seems like it has utility as well. In fact, I think I designed this director class to have 2 constructors. Yep. There's an alternative constructor that does that null for me. I don't know what the key is. We need to get that key. So I'll go ahead and remove that first argument there. There we go. It's just the key, the first name and the last name. Let's implement this. Now, having seen one example, you tell me, what's the first step? Make a connection, ... Right? Remember, this is a different function. This is a different method. You could call one and not the other, right? Each one needs to make its own connection. So what does that look like? Copy, paste. Right? Maybe there's a better way of doing that. Right? If I'm going to make a connection, make a connection, make a connection, I could put that into another class, and it's a connection factory. Right? It manufactures connections for me and keeps track of the username, the password, etc. Right? Probably a better pattern to follow, and it's worth bonus on your next assignments. Right? On phase 4, 5, whatever it is. Right? So I'll call this result because we already have a director D here. Okay. All right, and then ultimately we're going to return results. Result. There we go. There we go. All right, 2. Formulate your query. So what query do I want here? Select everything from... How do I select something out by name instead? Select everything from director. Where? What? I want Christopher Nolan here. Last name equals Nolan. Right? And do we want just the last name here? This is a good question. Right? What if there's Joe Nolan and Nolan and Ryan Nolan, right? Et cetera, et cetera. So, and first name is equal to Christopher. There we go. If we do that, then we get out the thing that we're interested in, director ID 2 here. Okay? So, copy, paste this over in here. Except that what? Do we want to hard code Nolan and Christopher? Nope. So do we put in a quote here and then concatenate it, and also, oh yeah, we also need to backtick those, or escape out those quotes when we use them in a string, etc., etc. No, do not do that. Question mark and question mark. Right. Now a note about style here. Remember that SQL is case insensitive. Really old school SQL folks will prefer doing something like this. Select, and then from, and then where, and. Why? Because it offsets the keywords from everything else. If you go back 40 years where you had monochromatic, monitors, green screens, you wanted to offset those keywords so that you could read it a little bit better. We don't live in that world anymore, right? We've got millions of colors on our high-def monitors now. Right? We use color coding to denote what's a keyword and what's not a keyword. However, over here, is there such a color coding within a string in Java? Nope. So if you want to, and I'm only suggesting it, you can go ahead and go back to the old school way of doing this. Select from director where, right, and. Right. If you want to do that, then make sure that you're in the market, you're prepared to pay for a new pinky, because you're holding down the shift button every single time. Right? What is it? RA, rheumatoid arthritis, right? I don't know if that contributes to it, but if eventually you get arthritis, then you will not want to do something like this, right? So I prefer doing something like this. Right? Your mileage will vary. You can do whatever you want. Just be consistent about it, okay? We've got our query here. Now I need to, again, copy paste. This one is okay for copy paste. Don't think that you can generalize this. You'll just end up reinventing a JDBC itself, right? Anyway, I've got a prepared statement, a result set. I prepare that query, and instead of setting integers, what do I do now? I have 2 parameters to set. ps.set string, that's the first parameter, and the first string is going to be last name. ps.set string 2, and then first name. Except that I don't have a first name and a last name, do I? I was given what? a director. So I need to use that object to get those fields. d.getLastName, d.getFirstName. There. Execute the query, process the results. Right? So here's the director ID from the database. Now, since I don't have a variable named director ID, I can go ahead and name that director ID. Right? And then result is equal to this new director with all three of those things. Do I need to pull those from the database if I gave them to the database to query? Probably not. Right? So I can go ahead and get rid of that. And then just copy these over. Or maybe, better yet, what if I had a copy constructor? Right? That'd be kind of cool. And very useful on your project. Hint, hint, again. Right? There we go. So let's see if this works. It should be Christopher Nolan being pulled out of the database successfully. And we should print him, I guess. Print out Nolan. Now, that default print that we're making here is only going to be first name, last name. So let me modify that so that we also have an ID here, this dot director ID, to verify that we actually got the right person. Does anybody remember what the director ID of Christopher Nolan was? 2? Select. In fact, it is. There it is. Yay. Okay. All right. That's 2 examples so far, but it only worked with 1 table. Let's go ahead and do one more example here today. We'll see how far we get through it. And get all the films. In other words, I want a data model or result set that looks something like this. Not exactly like this because I don't want all the duplicates, but I want all film records here. Okay. Before I do that, what did I forget? Clean up, right? So if it helps, write these 4 steps out each and every single time, and then fill them out, and then go back and remove those comments because that's cruft comments. That's cruft. Don't leave that. All right? Yeah.
Can we put those close statements in a method?
Say again.
Can you put the close statements in a method?
You could, yeah. So if you have a factory, what's the opposite of a factory where they take things apart? Disassembly factory, disassembly, whatever. Well, junkyard, right? you could even have that as a. You could pass in those 3 things. The problem is sometimes you don't have a result set. You just have 2 of those things. So you'd need yet another function, and then another function for just one thing where you've got the connection. So now you've got 3 more functions just to save yourself on 3 lines of code. You've traded 3 lines of code for three more lines of code. It's a wash. I wouldn't. Right? I would just do it directly like this. But certainly 20 lines of code repeated over and over and over again, probably not. In fact, we'll talk at the end here about best practices and advanced practices. You don't actually do this. You would set up what's called a data source, and then you would get connections directly from it. In fact, you would have what's called a connection pool. Making those connections is actually quite expensive to connect to a database. And then pull data. You're actually going to spend more time connecting to the database than actually pulling data. So what you can do is you can open up, say, 30 connections and then put them in a pool. And instead of opening up a new connection, you just take an existing connection and use it. Then when you're done with it, you don't close it, you put it back. And that's a little bit better solution. That's going way too far for your project, right? I would not suggest that. But if you want to try it, go ahead. All right, get all films. Step 1, step 2, step 3, step 4. What? Make your connection. Formulate your query. Prepare your results. Right? So let's go ahead and, actually, I'm just going to cut and paste all of it to show you what not to do. Don't do that. Right? But we'll start up at the top here. Make your connection, nothing changes. Except for, there we go. And I don't need that director there. Make your connection, formulate your query. I'm not simply going to connect to the director table here. What am I going to connect to? I'm going to connect to from the director to the film actor, actor. If I did that, let's think about that for a second here. If I did one big giant join statement, That's not that big of a deal, right? We've only got, what, half a dozen records, 8, 9, 10 records here. But we do have a lot of repeated data because we've flattened this data model, don't we? I will be sending Matt Reeves, the string Matt and the string Reeves, over the wire 4 times. Do I need 4 copies of Matt? Do I need, let's see, do I need 3 copies of Batman's EIDR? Batman 2022, Batman 2022, Batman 2022. Right? Probably not. Let's be more judicious about this. Instead of having one big giant join statement, let's go ahead and select everything from film. And then, based on that, we will go ahead and connect to the other things. Right? So from film, film F is equal to new film. Right? Actually, no, sorry, I'm going to do that at the end here. Right? I prepare my statement. I don't have, do I have any parameters to set here at all? Nope, I'm just going to grab everything from that film table. Okay? I execute my query, and then I iterate over each one of those results. I process the current record. Well, what's in a film? Select everything from film. Film ID, title. We'll go ahead and ignore the release date. We'll ignore the IMDb rating. We'll ignore the EIDR too. All I really need is the film ID, the title, and the director for this demonstration. All right? So I will be more intentional. I don't want all that stuff. I just want the film ID, the director ID, and the title from film. Then I'll get out each one of those things. The director ID, int film ID is equal to rs.getInt film ID. And then finally, string, which is the title, equals rs.getTitle, or string title. There we go. Now I've got enough to create a film. F is equal to new film. And let's take a look at the constructor order on that. It's going to be film ID, title, and director. Wait a second, what about that cast? So one pattern that we've seen with a lot of submissions is just a straight up naive kind of constructor where we also require the list of all actors immediately. Right? That's kind of what's called a leaky abstraction. First of all, it advertises to the world, we haven't been taking off for it, but we have hopefully been noting it in your code in code post, that you probably don't want to do this for 2 reasons. One is it's a leaky abstraction. It's leaking out to the world. How are we representing our cast? We're representing it as a list, right? Even worse would be if it was specifically an array list, right? Now it's really leaky. You're using an array as a list to represent your cast, right? Collection, right? That's a little bit more generic, but here's the second reason you don't want to do something like this, right? It forces somebody to have the entire cast list prepared when you create this film. Now think about that in terms of your own project. If you've got a person has multiple emails, right? Should you be forced to create an entire, outside of the class now, create an entire list of emails and then hand it over to another class just so that it can copy it into its own state? Right? That's not flexible. How have I designed this instead? We certainly have a cast, and in our constructor, we set it up to be an array list, but we don't force them to provide that cast immediately at instantiation. Instead, what do? We allow them to add actors later on, right? It's a little bit more flexible, right? Consider using some patterns like that in your project, right? But it's definitely going to be necessary, not necessary, but it's definitely going to be useful here when we need to create a film and we only have the film ID, the title, and the director. So film ID, title, and director ID. There we go. Except that, wait a second, director ID, over here in film, a director is not an ID. Just as, now we are taking off for this. If I have a person, is a person just a person code? No, this is bad modeling here. This is bad abstraction. What is a person in your project? It's a person, right? Like an owner, right? Or a beneficiary or something like that, right? All right, good. That is something that we were taking off of. I do not want just an ID here. I want like an actual director, a new director. Question mark. So do I have to write yet another query and do this and cut and paste that 4-step process all right here between lines 159 and 161? No. Why? I already wrote it. Right? Why do you think I wrote that to begin with? So that we would have access to that functionality. Right? So, create a director, D, based on get director ID and the director ID. Once you've got that, then you can just put in the director, D, and you're done. Right? Separation of concerns. Right? Now, this is getting a little bit big for a class. You could have an argument here that this is already a God class because it loads up directors, it loads up films, eventually it's going to load up actors too, right? If you put this all into one class, maybe it's getting up there, right? Split it out. For your project, if you have one data, think about your data loader class. You're going to load up assets, you're going to load up people, then you're going to load up accounts. You could split those out into three, at the very least, 3 functions, 3 methods, if not 3 classes. 3 things, that's not that big of a deal, though. You could probably leave that in one class, like a data loader class. Okay. All right. Are we done? We've got the film, but have we done anything with it? Nope. What does this return? A list of films. So let's make a list of films. Films, or results, is equal to new array list. And I will add f to it, films.add f. And at the end, instead of returning result, I will return films. There we go. Okay. Let's see if this actually works. And we still have what's wrong? Okay, import. There we go. Save that. Run it. Ooh, slow. There we go. It was slow getting started. Once it started, then it was lightning fast. Right? The Batman 10, directed by Reeves, Matt, starring. Right? Do we have any actors yet? No, because what did we not do? We didn't join to that other table. Right? So I don't know if we have time or not, but what would that look like? Before returning with my results here, what else should I do? Do another query, right? Load all actors for each film, ... right? What would that look like? You can reuse your query prepared statement result set if you want to, right? As long as you let's close them close everything except for the connection. Right? And then we can reuse them. Right? So string or query is equal to select everything from actor where actor ID is equal to something, right? We're not going to have time to do this, but do I start at the actor table? Nope. I have a collection of films, right? What connects an actor in a film? A film actor. So what do I need to do? I need to start at film actor, FA, and then here I will join. Do I need a left join or just a regular old join will do? Just a regular old join will do. Because if they are not attached to any film, or if there are no records in that join table, then obviously they didn't start in that film, and I don't need it, right? So join actor A on fa.actorID is equal to a.actorID, right? Where film fa.filmID is equal to, what was the Batman 1? Oh, no, what was it? The Batman is 10. There we go. So the result that we want for a particular film is going to look something like this. Robert Pattinson, and Paul Dano. Right? Robert Pattinson's in there twice because he has a different role, Batman and then Bruce Wayne. Right? So what is that going to look like? Cut and paste this query. Change this to a question mark, and you're good to go. Right? And be more judicious. Don't pull out. You can pull out. You can put a uniqueness in there so that you're not pulling Robert Pattinson out twice. But he does have different roles. So if you're modeling roles in your POJOs, your plain old Java objects as well, then you would need that data as well. Right? Or even better yet, maybe I write yet another function to load up all the actors. And then I don't have to make multiple connections to the database. I can just roll through all the actors, select the ones that are relevant, and then attach them to my my films. Right? We'll pick it up there next time, though. Okay. Same basic process. Open up a connection, formulate your query, execute your query, take care of your result set, close your connections, and you're done. There's not that much to it. Okay. All right, I'll see you on Thursday. Hopefully. Hopefully it won't be that bad.